Next one, say finding the value of a trigonometric function given information about an angle. This is problem type 1. So what we're doing is we're thinking about our graph and that this is my x direction and this is my y direction. So if I'm doing -2, -3, I would be over here in quadrant 3. Then I'm going to use my Pythagorean theorem to find out what my hypotenuse is. I know that a squared plus b squared equals my hypotenuse squared or my c squared, right? So here I would get 4 plus 9, which is 13. And so I'm going to have the square root of 13, keeping in mind my hypotenuse is always a positive number, square root of 13 then. Then I'm going to do my functions that they give me. Cosine is the adjacent over the hypotenuse. The secant would be the inverse of that, hypotenuse over adjacent. Cotangent is going to be the adjacent over the opposite, the inverse of my tangent. And so now I can look at my drawing here and say, okay, the adjacent side is -2, the hypotenuse is the square root of 13. So -2 over the square root of 13, of course, has to be rationalized. We can't have the square root in the bottom of our fraction. So we multiply by the square root of 13, and so we get -2 square root of 13 over 13, because we know that if we take the square root of 13 times the square root of 13, it's the square root of 169, which is a perfect square, 13. Because when we multiply two square roots by each other, it rationalizes it and gets rid of the square root. Secant. Secant is the hypotenuse, which is the square root of 13, over the adjacent, which is -2. Of course, we want the negative out in front, so negative square root of 13 over 2 is going to end up being our answer. And cotangent, the adjacent side, which is -2, over the opposite side, which is -3. Negative over a negative gives me positive, so 2/3 would be my solution. So we'll go ahead and take a look at number 5 and number 6 here. Number 5, let 6, -5 be a point on the terminal side of theta. So 6 in my x direction, -5 in my y direction. And then, of course, I want to find my hypotenuse using my Pythagorean theorem. So 6 squared plus -5 squared equals c squared. So 36 plus 25 gives me 61. Then I have to take the square root. So the square root of 61 would be the value of my hypotenuse. And this time we want to do cosine, cosecant, and tangent. So cosine is adjacent over hypotenuse. Cosecant is the inverse of my sine, so my hypotenuse over my opposite, tangent, opposite over adjacent. And so my adjacent side is 6 over my hypotenuse, square root of 61. Again, I have to rationalize the denominator. So I'm going to get 6 square root of 61 over 61. Can't simplify. That's going to be my first answer. Cosecant says we're going to do the hypotenuse over the opposite. So we're going to have the square root of 61 over -5. And again, since that's negative, we'll put the negative out in front. So negative square root of 61 over 5. And then for my tangent, I'm going to do the opposite over the adjacent. So -5 over 6. So -5, 6. And then number 6, same kind of thing. Draw my reference angle here. I'm going to go -2 in the x direction, 7 in the y direction. So -2, 7. Finding my hypotenuse. Negative 2 squared plus 7 squared equals c squared. So 4 plus 49 would be 53. And then I have to take my square root. So square root of 53 is going to be the measure for my hypotenuse. And this one we are going to do the sine, which is opposite over hypotenuse, the cosecant, which is that inverse of that, so hypotenuse over opposite, cotangent, which is the inverse of the tangent, so adjacent over opposite. So sine, my opposite over my hypotenuse. So I'm going to get 7 over the square root of 53, which we rationalize. So I get 7 square root of 53 over 53. Cosecant, we are going to do the hypotenuse, which is the square root of 53, over the 7. The opposite, square root of 53 over 7. Not much we can do with that one. That's just going to be my answer then. And then the cotangent, I'm going to do the adjacent over the opposite. So negative 2 over 7, so negative 2 sevenths. So just finding these by drawing our reference triangle, doing the Pythagorean theorem in order to find the value of our hypotenuse, and then plugging them into the formulas, if you want to call them formulas, for sine, cosine, tangent, cosecant, secant, or cosecant.